The vastness and beauty of the universe have captivated humans for thousands of years. No one can guess what mysteries lie dormant in the far reaches of space or what cosmic riddle lurks practically on our doorstep. Technological advancements have allowed us to peer deeper into the cosmos, but we still have a long way to go. If you are interested in space and the James Webb Space Telescope, then don't forget to subscribe to our channel so you make sure you don't miss out on any news and updates. Today we are talking about the somewhat strange discovery the James Webb Space Telescope has made on Jupiter. While it is common knowledge that the James Webb Telescope, a groundbreaking piece of equipment, will be used extensively in astronomical study in the next few years, technical advancements have allowed us to fill in more and more of the blanks on the star charts. It is hoped that Webb's mission will take humanity's understanding of the cosmos to previously unfathomable heights. What lessons can be gleaned from the gas giant's magnificent vision just recorded by the most powerful space telescope in history? That revealed decoding the universe goes far beyond the study of old galaxies and stars. With your help, we want to uncover what mysteries our solar system's monarch still guards. In most fields, pinpointing the exact moment when a new era of space exploration began is difficult, but in astronomy, December 25, 2021 represents that moment. Since the James Webb Space Telescope left our blue home planet and reached its target orbit 900,000 miles away, a lot has happened, including the presentation of the first Webb images to the interested public on July 9 of that year. The $10 billion Webb telescope was built with infrared astronomy in mind. This means it can observe objects from the red end of the visible spectrum all the way through to the middle of the infrared range. This will allow Webb to target the first bright galaxies and formations to emerge after the Big Bang and the subsequent dark ages. When and how the scientific debate on this topic will end is still up in the stars at the moment. But what we do know is that Webb recently gave us a completely new insight into a cosmic world that we have long known about, that of mighty Jupiter, king of the planets. No other planet in the solar system achieves the overwhelming dimensions of Jupiter. Experts generally distinguish between two groups in Jupiter's atmosphere, the lighter-colored zones and the darker belts, with the zones presenting themselves as plainly cooler and denser due to our encounters with them. While the existence of the solid planetary heart remains unverified, it has been known for centuries that the gas giant with a diameter of 89,000 miles does not travel alone through space and that the rising gases here are likely due to the contained ammonia ice. But it is not exactly clear why the belts are darker. Experts speculate that they contain sulfur, phosphorus, and possibly hydrocarbons. As early as 1610, the 4 Galilean moons, Jupiter's largest and best-known natural satellites, were added to star charts. Today, we know that Jupiter has at least 79 natural satellites. Thanks to the deployment of numerous unmanned space probes, Jupiter is also known for being the scene of extreme weather phenomena, most notably the Great Red Spot, a remarkably persistent storm system that is currently about 1.5 Earth diameters in size. With the revolutionary NIRCam of the James Webb Telescope, we can see the cosmos in a whole new light. A quick classification: Webb reacts up to 100 times more sensitively to electromagnetic waves than its predecessor Hubble. So, in theory, the device would be able to detect the heat of a bumblebee on the lunar surface of the Earth. However, getting back to the Jupiter images, they prove once again that Webb's often quoted performance is all about the aforementioned NIRCam. It used 3 filters to capture light reflected from the gas planet. Within this framework, it is possible to analyze an image on the infrared radiation of different spectra separately. However, because this infrared radiation is invisible to the human eye, the corresponding wave bands were translated into the visible color spectrum, and the resulting image proves to be so rich in detail that we can even recognize the small satellites. The illuminating photograph stunned even the most seasoned scientists. And now that we've explored Jupiter's neighborhood, we can turn our attention to the gas giant itself. In this close-up view of Jupiter, we can see the auroras glowing red at Jupiter's north and south poles. Yellow-green haze formations above the Arctic areas have become more dense. Veil clouds, on the other hand, have a bluish hue in the lower cloud bands. Even while the Great Red Spot doesn't quite live up to its actual name on the accompanying motif, it is still plainly visible. Although experts have studied many of the features captured on image before, the James Webb Telescope opens up an entirely new perspective on the familiar features. The large storm system appears as a radiantly bright structure due to its high back radiation, and the brightness also reflects the great height of the object. Since the Great Red Spot and the auroral regions have always been shrouded in mystery, scientists are hopeful that these photographs will help them finally unravel the mystery. The greatest storm formation in the solar system has been rolling over the gas giant since at least 1831, but astronomers in the 17th century had already noticed a very massive region in Jupiter's atmosphere. The anticyclone, which can reach speeds of up to 423 miles per hour, remains a galactic mystery despite decades of study. For example, we still don't know for sure why it appears in a reddish hue. Possible explanations range from phosphorus and sulfur compounds to organic material. Jupiter's lack of a strong magnetic field also likely contributes to the object's remarkable longevity. There is no currently accepted hypothesis that can account for all known details about the enormous red spot. What is known, however, is that the structure is sometimes subject to drastic flux situations, and this applies not only to the changing hue and orbital velocity but also to the changes in size. For instance, in 2017, it was given at 10,159 miles, whereas in the late 19th century, the value was just under 30,000 miles. For over a century, astronomers have tried to solve the stormy mystery. In 1881, C.W. Ho proposed the so-called raft theory. According to Patrick Wynn's logic, there are four possible causes driving the storm system in Jupiter's atmosphere, one of which is barotropic. With this type of shear, air density is determined purely by pressure instead of temperature. Local forcing in the form of moist convection and smaller storm vortices are also considered by the baroclinic shear, which incorporates temperature considerations. Only time will tell which factors really underlie this exciting mystery. And who knows, perhaps the Webb images of Jupiter will be instrumental in finally unraveling this great mystery. What is your look on this? What do you think about the spectacular Jupiter images from the James Webb Space Telescope? Thank you for watching this episode of Space News Unfold. Like this video, and subscribe to our channel to make sure you don't miss any news about the James Webb Space Telescope. We have another incredible video ready for you. Click on the video on your screen and let us take you on another space adventure. See you there.